Alright, and here's the continuation of the 5354 video, but this is just 5/4. This is factoring. So the first thing we're going to do is we're going to just talk about finding the greatest common factor. This is pretty easy. We're just finding the thing that goes into all of these. Well, I see that a 2 goes into all of these, an x goes into all of these, and a y goes into all of these. And at most just one x, and at most just one y. So let's pull out a 2x, y, and let's see what would be left. Well, we'd have a 3xy minus just a y plus a 3x squared. And that's it. That's how you factor using the greatest common factor. Do the same thing here. I'll put the answer up in just a second. Okay, for this one you can pull out a 3 and an x squared out of every single term because they all have at least an x squared in them and a y. So you have 3x squared times 3y squared minus y plus 2x. Okay. Sometimes when you have a lot of terms, you can do what's called grouping. And this is kind of nice. So there's not something I could take out of every single term, but what I can do sometimes is I can split it into two parts. And I could ask myself, is there something I could take out of just both of these terms? And there is. I could take an a squared out of both of these terms, leaving me with just an a minus 4. And then I'm going to say, well, is there something I could take out of just these two terms? And I could take a 3 out of both of these terms. So I pull out a 3 and I would be left with an a minus 4. Well, I could write it just like this. But since these are the same, this is kind of the reverse distribution property. And I can move the a squared and the 3 together, put those in parentheses, and then just times that by 1 a minus 4. And that would be the same thing. And that's called grouping. Okay, why don't you guys try that one with this guy. And pause the video, I'll put the answer up in a second. Alright, if you split this one in two parts, you see here that you could take a 3y squared out of both terms. You get a 5y plus 4 left. Here you take a 2 out, and you get a 5y plus 4. These two things are the same, so you can bring the 3y squared and the 2 together, and then bring down the 5y plus 4. Okay, this is all really just setting us up, though, to be able to factor guys like this. So when we do guys like this, there's several ways to factor these trinomials that go from squared to x1 to x0. But I'm going to teach you the magic x way, which involves you recreating this x. You put a times c on top, b on bottom, and you put your a here on bottom. You need something that'll multiply up to a times c and add up to b to go in these two spots. So let me show you how it works. Let's make my magic x here. I'll zoom out so we can see both the original. Okay. I'm going to put my a times my c on top. A being 5, b is c. So that's where that a comes from. I'll go like this. Ax squared plus bx plus c. That's where those a's and c's come from. So a times c is 30. And my b is negative 13. So I need something that'll multiply up to 30, but add up to negative 13. And this is probably the hardest part for some people. Just take some thinking. And the answer is going to be negative 10 and negative 3. Negative 10 times negative 3 is 30, and negative 10 plus negative 3 is negative 13. Then remember, I'm going to divide by my a, which is 5. Okay, these little fractions that I get on the side, these are going to help me determine what my factors are. If I can reduce it, like here, negative 10 divided by 5, well, that's just negative 2, right? Then my factor is just x minus 2. Boom, I'm done. But this one I cannot reduce, so we do what's called bottoms up. I take the 5, I move it up, I put the x with the bottom, minus 3. So these are my two factors, x minus 2, 5x minus 3. There you go, that's all there is to it. I'll let you guys try practice number 6. Go for it and I'll explain how to do this one in just a little bit, but I want to give you guys a chance to try it. Okay. Alright, so here's my x. Remember I did 4 times 3 on top, 7 on bottom, and then I put my a terms on bottom here. And I'm looking for two numbers that multiply up to 12 but add up to 7. And what do you know? It's actually 4 times 3, right? 4 times 3 is 12, and 4 plus 3 is 7. So that's easy. Put a 4 here, a 3 here. Does 4 over 4 reduce? It does. It reduces down to 1. Does 3 over 4 reduce to a nice, neat, even number? It does not. So my factor over here is just going to be an x plus 1. Boom. And over here, I have to do the bottoms up. So it's 4x plus 3. There we go. So there's my two factors. And if this was a minus, that would be a minus. If this was a minus, that would be an x minus 1. Pretty simple. And if you multiply these guys back together using the box method, you should end up exactly what you started with. So there's factoring using the magic x. Alright, let's go to the next page. Here, what happens if you run into things that just don't factor nice and neat? Like these guys won't just factor nice and neatly. So somebody a lot smarter than me a long time ago went through these and figured out that these guys will always factor into a certain pattern. And so these are the 5, if you see these 5 patterns, you need to memorize how they break down. And these are the 5 ways to break down. If you need to make flashcards to do it, then do it. But you need to memorize these 5 situations. Probably the harder ones to memorize are the a cubed plus b cubed and the a cubed minus b cubed. This is the sum and difference of 2 cubes. So we have a couple of tricks to remember these. First, you got to remember the pattern a squared, a times b, b squared. If you can remember that pattern, then you'll be good for both of these because they both follow the same pattern. See, a squared, a times b, b squared. The only difference is the signs. So to know what to do with the signs, came up with this acronym SOAP, and that is that you go same, opposite, always positive. Okay, and what that means is, look, if this is a plus sign, this is going to be the same, opposite, always positive. If this is a minus sign, it's going to be the same, opposite, always positive. And there you go. So those work out nice and neat. Now let me show you how they work. Okay, we're going to go here. Look, these are obviously a different, or the sum of cubes. We have a cube and a cube, and this is going to be a cube. I'll show you how it breaks down. So real quick, I'm going to copy this thing down just so we have it. It's a plus b, and then a squared minus ab plus b squared. Okay, let's zoom in and see how we can use this. Alright, first we need to rewrite this as, remember how it looked at the top? It was a cubed plus b cubed. So we need to figure out what our a and our b is in order to plug it into this thing. Well, I can rewrite this as a cd cubed plus, can I write 27? Rewrite that as a cube? I can, because that is 3 cubed. There we go. So my a is cd, and my b is just 3. So I just go and rewrite it. I'm going to write this as cd plus 3 in parentheses, and then I'm going to write cd squared minus a times b, which is cd times 3, so I'd write that as 3cd plus my b squared. Well, that's 3 squared, so that's just 9. I could simplify this a tad. I could say cd plus 3 times c squared d squared minus 3 cd plus 9. That's it. That's as far as it'll factor. And so that is the factored form of this guy up here. So when you have a sum of perfect cubes or a difference of perfect cubes, you can use this guy nicely. So I want you guys to use the same pattern, same formula here, except for the signs are going to be switched because this is a sum of cubes and this is a difference of cubes. So when we get here, hopefully you'll see now we're subtracting, so we're going to use this pattern. And some of you guys are saying, well, this is to the 6, it's not to cubes. Well, that's true, but you could rewrite this as m squared to the 3rd minus n squared to the 3rd. So your a and your b would be m squared and n squared. That's fine, you can do that. So remember, you can use this bottom one, here's your a, Here's your b, and just plug it in. And so try and rewrite it right underneath there, and I will show you the answer in just a second. Pause the video now. Okay, so if your a is m squared and your b is n squared, it would be a minus b. A squared would get you m to the fourth, a times b, and then b squared gets you n to the fourth. And then that's it. So you have factored successfully. You factored this thing down. Now, here's the thing. Look at this guy. This is an m squared minus an n squared. So this part right here is actually a perfect square minus a perfect square. Well, let's go back up here. I have the difference of squares formula right here, which breaks down to a plus b and a minus b. So I can actually break this down even further. And so I could say that this is the same thing as m plus n times m minus n. And then put in this whole m to the fourth plus m squared, n squared plus n to the fourth. And now I really have this thing pretty much factored as possible. There is another way to factor this. You'd get a slightly different answer, but this is an acceptable answer for me. I'm not really going to go into detail explaining the other way, just that this is an acceptable answer. Okay. I'm going to do this last one for you guys down here because it's not a nice, neat, perfect square, because 48 is not a perfect square, neither is 3x. So we need to see what we can do to this first. So let's take a look. And I'm going to have to pull out a greatest common factor. Can I pull out a 3 out of both of these? Yes, I can. Can I pull an x out of both of these? Yes, I can. So I'm going to rewrite this as 3x times y squared, and then 48 divided by 3. Well, what is that? Well, 48 divided by 3 is 16, so this is going to be y squared minus 16. Okay, well, isn't y squared minus 16 the same thing as y squared minus 4 to the second? I'm doing that because I know that this is a perfect square. I want to know if this is a perfect square, because if it is, I have a difference of squares, which means I can use that pattern that I just used in the last one and break this down to 3x times, that's an x, y minus 4 times y plus 4. And there we go. And that is, that's as factors as I can get. For this last one, it's kind of a doozy. You're going to need to use the x factor on both of these. I want you guys to try it. Try to do the x factor, the magic x on top, magic x on bottom. Write out what you get, and then I will explain the rest from there. So go ahead and try that. Okay. So we factored this out. You should have got x minus 1, x plus 3, and x plus 3, and x plus 4 using the magic x. Here's me doing it over here, just real quick little work. But this should be an easy one because there's no a term, so when you're dividing by 1, you just get the same thing back. Okay. I shouldn't say there's no a term, I'm sorry. That's really a 1 there, but it makes it really easy for us. Couple things. So some of you guys probably see, hey look, this x plus 3, this x plus 3, they cancel out. Well, that's true, but before we cancel that out, we have to ask ourselves, if I was to plug in a negative 3 here, what would happen to my expression? Negative 3 plus 3 is 0. 0 times anything is 0, and I'm not allowed to divide by 0. So, we have to make a little side note right now. The side note is that x cannot equal negative 3. It also cannot equal negative 4. This is a little restriction that we have to place on x so that when we get to our final answer, we know, hey, look, yeah, we have an answer, but this is some restrictions on what our answer is. So now that we've canceled out the x plus 3's, we can write our final answer as x minus 1 over x plus 4 with the restriction that x cannot equal negative 3 or negative 4. Okay. That's it for factoring. See you guys in the next video.